Now, in finding the volume of solids of revolution, we usually have the disk method or the cylindrical shell method. So, when we rotate, this will be the method that I'm going to use. I rotated the axis. I rotated the x and y axis. If suppose given an equation f of x y equal to 0, and then we change the coordinates from x, y to a new system that is x prime, y prime, then we will have a resulting parametric equation which is x equal to g of x prime, y prime, and y equal to h x prime, y prime. Okay? And the change of coordinates now will relate the coordinates of a point in one coordinate system to those of the same point in the different coordinate system x prime, y prime. And hence, equation 1 defines the transformation of point x, y to x prime, y prime, where the origin is held fixed, meaning we won't change the origin. We are to rotate the x, y axis in terms of an angle, a counterclockwise angle, as shown in figure 1. Okay, so the point here, you have two different axes, but you have the same point. And in that case, we could have the coordinates of if the x and y axis are rotated to an angle to form the new axis x prime, y prime, then the relationship is described as follows. We have x prime is equal to x cosine theta plus y sine theta, y prime equal to negative x sine theta plus y cosine theta, or x equal to x prime cosine theta minus y prime sine theta, and y equal to x prime sine theta plus y prime cosine theta. So in this particular rotation of axis, we could also rotate the figure itself. However, in my procedure, I rotated the axis. In that case, there will be no change of figure. We have the same geometrical figure. So as I mentioned a while ago, if you have a region bounded in xy plane which is to be rotated about the line y equal to mx plus v, that will be the rotation of axis, that is the oblique axis. So as to have a horizontal axis of rotation, rotate the x and y axis to an angle equal to the angle of inclination of the axis of rotation. And hence, the axis of rotation will map now to x prime axis, and that is a transformed axis of rotation. Or in some case, we could have the oblique axis parallel to the transformed axis of rotation. So this is what I'm telling a while ago. It will be the region. So by using the disk method, I could now have the volume to be equal to pi times the integral of y prime, the new axis of rotation, y prime squared and then dx prime squared, or by substituting the value of y prime, the new coordinates of y prime, and similarly coordinates of x prime, wherein f of x will be the equation of